Namaste friends. Today our topic goal is to learn about the Coulomb's law in vector form. So in last class what we discussed means the Coulomb's law in scalar form F is equal to K into Q1 Q2 divided by R square. This is the scalar form of the Coulomb's law. Now our goal is to learn about the what is the vector form of Coulomb's law. For this one we are assuming that when the point charge is Q1 is located at a distance of another point charge of Q2 with a separation of distance of R. As the vector form we are measuring this one, we need to take the vectorial coordinates. Let me take the origin is here. Somewhere we are taking the origin. So Q1. Let me take the first of all we are here, the origin is there. We are measuring the distances from Q1 reference. So now as the two charges are in the same polarity, that means two are the same poles, that is the positive charge, two are the positive charge or two are the negative charge. So this is the like charges here. Then the like charges according to the Coulomb's law definition, the repulsion force will be act on the two charges. Here is the direction of the repulsion force direction. Why I am drawing this repulsion force direction along the line joining between the two charges means according to the definition of the Coulomb's law. See this force F21, we need to denote this F21 because of the force of repulsion which is acting on the second charge with respect to the first charge. This force is acting on the second charge due to the first charge. Now here we need to write the force of repulsion which is acting on the first charge due to the second charge. This is the force of repulsion which is acting on the first charge due to the second charge. Now let me go to the first one. Let me take the first one. The force of repulsion which is acting on the second charge due to the first one is equal to then K into Q1 Q2 divided by R square. So in which direction this force is acting? Along the direction of R. What is the distance from this one? From we are measuring from this origin of the Q1. So that means how much distance is there? That is equal to R12. So we need to specify the distance. That means distance is represented by the R cap. So here is the R square is there. What is the distance? This one R12 distance is there. Here R is nothing but R12 distance is there. So I know you are familiar with the unit vector of A cap is equal to the vector of A bar magnitude of A bar. In the similar fashion, so what is the unit vector of R12? R12 is nothing but R12 bar divided by R12. So this is the magnitude of R12. I hope you understand how I written the R12 cap. Now let me go to the previous formula. What is the force on the second charge with respect to the first charge? F21 bar is equal to the K into Q1 Q2 divided by R12 square into R12 cap. Instead of cap I need to write the vectorial form, that is equal to Q1 Q2 R12 square into R12 cap is equal to here is there, that is equal to R12 bar divided by R12. So R12 is nothing but it is the magnitude of the vector. Can I write this one like so? That is equal to force on second charge due to the first charge is equal to F21 bar is equal to K into Q1 Q2 divided by R12 whole cube. Can I write, because of here R12 square is there, here R12 is there, R12 cube into R12 bar. This is the vectorial form of Coulomb's law. It is the vectorial form of the Coulomb's law. I hope you understand. So now will you please, this is also vectorial form of the Coulomb's law because of it is a unit vector form. It is the vector form of the R12 bar. In the similar fashion, could you please tell me the what is the force on first charge due to the second charge? F21 bar. That means we are measuring the values from the second charge. So that means here is the second charge is there Q2, here is the first charge is there Q1. So from the second charge to first charge we are moving like this direction. So the force is like this direction, F12 bar. What is the direction of the F21 bar? So it is the from left to right from right to left direction is there. So here also k into q1 q2 divided by r21 whole square into r21 cap, r21 cap we need to get. So this is the vectorial form of which is the force is acting on second charge, on the first charge with respect to the due to the second charge. So will you please understand the direction of the r12 cap is exactly opposite in the direction of r21 cap. I hope you understand with help of the vector notation. Will you please look on this one? This is the r12 direction, sorry, r21 cap direction. So we are coming from 2 to 1 direction. So r21 cap direction. Now will you please take the r12 cap direction? This is the first charge, this is the second charge, that is equal to q1 charge, this is the q2 charge. So along which direction is there? That is equal to r12 cap direction. Will you please look at this one? r21 cap is opposite in the direction of r21 cap direction. That means we can get the conclusion some f21 bar is exactly opposite in the direction of f12 bar. Are you getting? I hope. So the force of repulsion which is acting on the second body due to the first body is exactly in opposite in the direction of the force which is acting on the first body due to the second body. So this is the very important one. Now we concluded that what vectorial form of the Coulomb's law, and also some of the conclusions are there. The force which is acting on the second body is exactly identical equal to the force acting on the first body due to the second body. That means here the Newton's second law is acting. So the Newton's second law is acting, Newton's third law is acting here. So from the Newton's third law also the force which is acting on the first body is identical equal to the force which is acting first body. Both are in opposite direction according to the Newton's third law. The same law is applicable in this situation also. Now we can conclude here what is the vector form of the Coulomb's law. This is the vectorial form of the Coulomb's law. Thank you for watching. Thank you.